Hello students, hope all of you are well. Today I welcome all of you to this session where we are going to discuss about the change of variables while doing the multiple integrals from Cartesian coordinate to the polar coordinate system. This is one of the most important and interesting topic to understand, and from here also we will get some of the questions in competitive exam as well as in our semester exams also. So let us start. So before we are going to the topic, let me just give you a brief discussion why we should change or do the conversion from the Cartesian coordinate system to some other coordinate system. So in the previous video lectures I have discussed about the evaluation of the multiple integrals for the constant limit case as well as for the variable limit case, where we have seen we have to draw the region in the xy plane. Thereafter we have to find out the limits of the variables and we have to do the integration. Now sometimes it can be difficult to perform the integration based on the limits of the region they have prescribed to us, and it will be quite difficult to find out the limits also. But if we change the coordinate system from one Cartesian coordinate to some other coordinate system, maybe polar coordinate, maybe cylindrical coordinate, so the integration will become little bit easy and quickly we can come to the solution of the problem. So that's why that is the need of this topic. But in our syllabus only we are having the conversion formula from the Cartesian coordinate to the polar coordinate system, so we are focusing on this topic only. But this formula, whatever I am going to derive right now, this is applicable for the other coordinate system also. Now let us try to understand the basic understanding or the basic formula derivation for changing from Cartesian coordinate system to the other coordinate system. Suppose we are having the coordinate system is given in terms of x and y. Now we want to convert the coordinate system from x, y to some other coordinate system that is depends on u and v. Suppose the transformation function we use here, x is a function of uv and y is another function of uv. Okay, so here initially we have to think that the coordinate system it is a prescribed or given that is x and y, but we want to convert the system now in terms of u and v. Now how to do the conversion from the xy plane to the uv plane? The conversion formula can be written in this manner, that is double integration over r f of xy dx dy. If it is given to us, now we have to convert this into some other form. Since x is a function of u and v, y is a function of u and v, so in place of x and y we can put uv, so it will become a new function. So it will become function of uv, guv. Here I have written the domain r1 to r as r1. Okay, so after the transformation it can be that whenever we will draw the uv plane, then the diagram will look little bit easier, but the regions r and r1 basically identical. So if we are drawing the region r in the xy plane and we are drawing the region r1 in uv plane, basically these two diagrams are just identical. But just replacing x by uv, y by uv, it is not sufficient. How to get the rest of the terms? In the integration in over r we have to do the integration with respect to x and y, so it is dx and dy. Whenever we convert this dx dy into uv plane, it will become Jacobian into du dv. Jacobian into du dv. So what is this Jacobian? Jacobian already we have learned in the previous semester, that is mod of j. Here it is representing the Jacobian of xy with respect to uv. So x and y is the given coordinate system and u and v is the transformed coordinate system. So with respect to the transformed coordinate system we have to find out the Jacobian. So how to calculate the Jacobian? That is del xy divided by del uv, that is del xy upon del uv. So how to calculate this Jacobian? All of you know the formula of the Jacobian is the determinant of this matrix, that is del x del u, del x del v, del y del u and del y del v. Okay, so using this Jacobian formula we can calculate the Jacobian of xy with respect to uv, and thereafter we have to substitute this Jacobian value in the transformed integral, so to get the formula. Now in our syllabus we are having the transformation from the Cartesian coordinate system to the polar coordinate system. So let us bring the formula for the polar coordinate system. So suppose, for your understanding, I have given one diagram on the right hand side that you can see. That is, here we are having the x axis and y axis in the Cartesian coordinate system, and say we are having a curve. That curve is given by y equals to f of x. Say this is the curve which is given by y equals to f of x. So the curve is in the Cartesian coordinate right now. Now if we want to change it into the polar coordinate system, along the x-axis we have to consider the initial line, that is an overlapping line with the x-axis only, because in polar coordinate system only we are having one axis, that is known as the initial line. It will start from 0. Now if we take any point on the curve for polar coordinate system, the point is having the coordinate as p, r, comma theta. How to measure this theta? Theta will be taken into anti-clockwise direction from the initial line to the curve, where we will make the tangent, and this tangent is having the angle of intersection, that is the theta. The distance, sorry, this is a distance, not the tangent, and the distance between 0 to p, that is given by r. Okay, so this is the representation. Now if we want to convert the Cartesian form to the polar form, what we have to do, we have to make the transformation as x equals to r cos theta and y equals to r sin theta. So here r is the distance from O to the point P, okay, and theta is the angle from the initial line to the distance, that is the r, that we can measure. Now since x is given in terms of r and theta, y is given in terms of r and theta, so we can calculate the Jacobian, okay, value of the Jacobian. So that is Jacobian of xy with respect to r theta. So del x del r del x del theta del y del r del y del theta. So whenever we will calculate this, x equals to r cos theta, del x del r is going to be cos theta only, y equal to r sin theta, so del x del theta is going to be minus x into sin theta, okay, and y equal to r sin theta, so del y del r is going to be sin theta, and del y del theta is going to be r cos theta. Now you know that how to find out the determinant. We have to just cross multiply and put the minus sign in between. So we get r into cos square theta plus r into sin square theta. So the Jacobian value is coming here as r only. So what will be the conversion formula from the Cartesian coordinate to the polar coordinate system? That is double integration over r f of xy dx dy. It is going to be double integration over r1 g of r theta, because in place of x we are going to put x equal to r cos theta and y equal to r sin theta, wherever we are getting x and y. Thereafter it will become a new function of r and theta, so that is the function g r theta, and this dx dy, it will be replaced by Jacobian into dr d theta. Since the Jacobian value is r here, so we get the value of dx dy as r into dr d theta. Now let us come to the solution part of different types of problem. So first of all, the problem is given as evaluate integration 0 to a integration y to a x square dx dy upon x square plus y square 3 by 2 to the power 3 by 2 by changing into the polar coordinate system. Okay, so before we start the problem, first of all, based on this information, we have to locate the values of the limits for the variables. So here the first function is dx here, and it is given y to a, so definitely it is a limit of x. Secondly, it is the limit of y. So here the limit of x is going from y to a and limit of y is going from 0 to a. So based on this information we have to draw the diagram of the region. So here we are having x-axis and y-axis. X equals to y, that is the straight line, x equal to y. Then x equal to a, which is the perpendicular to the parallel to the y-axis, x equal to a. Y equal to 0, y equal to 0 means x-axis, and y equal to a parallel to the x-axis. Now how to locate the region? Which region is the region over which the integration is taking part? Because I have told you in the last video lecture also, the region will be find out using the variable limit case only. So x is going from y to a, and always remember x we measure along the horizontal direction. So this is the region, x is starting from y and x is going up to a. So over this region basically we have to perform the integration. Okay, now we have to first convert this in terms of the r and theta. So we put x equal to r cos theta and y equal to r sin theta in this expression. But whenever we convert it into the terms of r and theta, so you can remember that the limits are also going to be changed, and limits are now it will come in terms of r and theta. So we have to find out the limits of r and theta. So how to find out the limits of r and theta? Theta is quite easy to identify for this region, because from initial line theta can be taken up to y equal to x. So since this line is making 45-degree angle, so theta is going to be 0 to pi by 4. So it is a constant limit. The value of theta is going to be 0 to pi by 4. Now r, it will start from origin or o, and it will maximum go up to this line x equal to a. It cannot go beyond the line, and you can see if I draw the green lines, then the length of the line will vary with respect to the line x equals to a. So what is our x in terms of r and theta? X equal to r cos theta. Along the line x equal to a, it will become a equal to r cos theta. So basically the value of r is coming in terms of theta, so it will become a variable limit here, that is a upon cos theta. So r will start from 0 and it will go maximum up to a upon cos theta. So we can write down limit of r as 0 to a upon cos theta. Okay, so we will come to the left hand side right now. So we substitute all these concepts here. So what it will become? So since theta limit is constant limit, so we can take it at outer integral, that is theta equal to 0 to pi by 4 and r equal to 0 to a upon cos theta. X square is r square cos square theta, and x square plus y square is r square cos square theta plus r square sin square theta to the power 3 by 2 into r. So from the denominator it can be easily understood that it is coming r square, and r square to the power 3 by 2, basically it will come r cube from the denominator, and also in the numerator r square into r is there, so it will become r cube in the numerator. Denominator also r cube is coming, so r cube are getting cancelled out, so we are getting the simplified form as cos square theta dr d theta. So since we have to perform with respect to r first, so cos theta related term will be considered as constant only. So cos square theta will be taken out of the integral, and we can see that it is coming integration r equal to 0 to a upon cos theta dr. So integration of dr is r from 0 to a upon cos theta, it will coming as a by cos theta into cos square theta. So after simplifying we get the value as a cos theta only. So a will be outside, integration of cos theta is sin theta, limit we have to substitute 0 to pi by 4, so the answer is coming as a by root 2. So this is the way that you have to make the conversion from the Cartesian to polar and then perform the integration. Let us come to the next problem. Evaluate integration 0 to a square root over of a square minus x square e power minus of x square plus y square dy dx. So definitely from the limit you can be able to understand the first limit is of the limit of y and second limit is the limit of x. Okay, so we have to write down y equal to 0 to root over of y square minus x square, and x will vary from 0 to a. So now y equals to root over of a square minus x square. So basically it will come from here y square equal to a square minus x square. So actually it is x square plus y square equal to a square. So what does this represent? It represents a circle, right? So we are having a circle centered at 0 having radius a. So we have to draw the diagram like the below, that is x-axis and y-axis. So we are having the circle which is centered at a point 0 and having the radius a, right? So x is varying from 0 to a, so this point is going to be a comma 0. So this distance is nothing but our a distance, and it is a fixed distance because it is a circle. So radius of the circle will be always a everywhere, and y is going from 0 to the boundary of the circle, and y we measure vertical direction. So we have to shade this region by the vertical lines, as I have mentioned in the previous video lecture. Now how to get the values of r in terms r and theta? So similarly like the previous problem, here we have to make a straight line. So this line from 0, this is the coordinate point P having the coordinate r comma theta. So how to get this whole region? So the whole region can be obtained if we rotate theta from 0 degree to the pi by 2, because this is the 90 degree, right? This portion, that is the only one half that we can see in the positive side of the coordinate x and y plane. And how to measure r? R is also becoming constant because this is the radius of the circle. Radius of the circle will be fixed, so it will be 0 to a. So the limits are becoming very easy. So theta is going from 0 to pi by 2 to obtain the shaded portion, and r is going from 0 to a. Okay, now we will come to the solution part. So here the integration is given as 0 to a, y equals to 0 to root over of a square minus x square e power minus of x square plus y square dy dx. So we have to convert, since both the limits are constant here, so with respect to whatever your choice of the variable you can perform. There is no restriction if the limits are constant. That I have made it clear in the first video lecture of this session. So since theta I am taking it outside, theta equal to 0 to pi by 2 and r equal to 0 to a, e power minus of x square plus y square, it will become r square, and here dy dx it will be replaced by r dr d theta. Now how to perform this integration with respect to r? So separately I have done this integration because here we have to do the method of substitution. So here r square we have to substitute as new variable z. So differentiate r with respect to z, we get 2r dr equals to dz. So what is the value of r dr? That is equals to dz upon 2. So integration of e power minus r square into r dr, this is becoming 1 by 2 integration of e power minus z dz, because minus r square we are putting r square as z, so it is becoming e power minus z, and r dr is becoming dz upon 2. So 1 by 2 I have taken outside, it is coming dz. So integration of e power minus z is minus e power minus z. 1 by 2 is coming here. Now lastly we have to substitute z equal to r square, so it is coming minus e power minus r square divided by 2. So make you understand, I have done this integration in the indefinite mode, but here we are having the limit, so we have to come back to the integration. This part already we have done separately. Now we are substituting this value inside the integration. So now I equals to, that all of you can see, I equals to integration of 0 to pi by 2 minus of e power minus r square by 2 0 to a. So after putting the limit, we are having 1 minus e power minus a square divided by 2. Okay, because if we put r equal to a, it is coming e power minus a square. By putting r equal to 0, we have e power 0 equal to 1. So putting upper limit and lower limit, we are having this term. Since this term is free of theta, so we can take it outside of the theta integration, and inside theta integration only it will take part 0 to pi by 2 d theta. So 0 to pi by 2 d theta, it will simply come pi by 4 into 1 minus e power minus a square. Okay, now let us come to the third problem and the last problem of this topic or this lecture. So now we are going to evaluate integration 0 to a 0 to x cube dy dx upon root over of x square plus y square. So here you can understand that y is having the limit 0 to x and x is having the limit 0 to a. So first of all, we have to write down this. Y is having the limit 0 to a and x is having the limit 0 to a. Now as per this, we have to draw the region, so we have drawn it. So here x axis and y axis, y equals to 0, that means our x axis, y equals to x, this is the line, y equals to x equals to 0, that is our y axis, and x equals to a, this is the another line. Now how to identify which region we have to shade? Because here with the variable limit we will be able to understand it. Y is going from 0 to x, so y equal to 0, that means x axis, then y is going up to x. So we have to shade this lower triangular region by the vertical lines only. Okay, so here we are just shading this lower triangle. Now how to get the value of r and theta? Same likewise we have done earlier. So from here we have to just draw a straight line. So up to this y equal to x, you can identify the value of theta. So theta is going from 0 to pi by 4, because y equals to x is making 45-degree angle with the positive x axis, and if we consider this is the line as r, so r is going from 0 to x equals to a, up to this line maximum r is going, right? So x equal to r cos theta, x equal to r cos theta, and x equal to a, we have to put a equal to r cos theta. So we get the value of r as a upon cos theta. It is quite similar to the problem that we have learned in the first problem. So now we have to make all this substitution. So x is going from 0 to a, y is going from 0 to x, x cube root over of x square plus y square dy dx. Here we have to change theta from 0 to pi by 4, r is going from 0 to a upon cos theta. So x cube equals to r cube cos cube theta, root over of x square plus y square is root over of r square, and dy dx will be replaced by r dr d theta. So here after simplifying, we are having r cube into dr d theta into cos cube theta. Okay, since cos cube theta is free of r, so it will be treated as constant whenever we perform the integration with respect to r. Okay, so r cube integration is r to the power 4 by 4, and we have to substitute r equal to a by cos theta as the upper limit and 0 as the lower limit. So it will come cos cube theta into a to the power 4 by 4 into cos to the power 4 theta. So a to the power 4 by 4 I have taken outside. Cos cube theta cos to the power 4 theta will be cancelled out. So we get d theta upon cos theta. 1 by cos theta is nothing but our sec theta. So sec theta integration formula is log of mod of sec theta plus tan theta. That is the formula for the integration of sec theta. Now we have to put the limit 0 to pi by 4. If I put sec pi by 4, the value is root over of 2 plus tan pi by 4, that is 1, minus log of sec 0 equal to 1 plus tan 0 equal to 0. So we are having log 1, but log 1 value is 0, so we don't have this part. So our final answer is a to the power 4 upon 4 into log of root over of 2 plus 1. So with this we are going to end this video lecture. Next video lecture I am going to discuss about the application of the double and triple integration to find out the area and the volume of a region and the closed domain. Thank you all.